When life-threatening storms approach, they bring catastrophic effects like floods, tornadoes, and severe hail. Decision-critical information is essential, and speed is key in preparing and responding to all threats. Today's typical weather visualization lacks necessary depth and detail. StormQuant's technology, as demonstrated below, combines a myriad of data from all available sources for a seamless user experience. NOAA and National Weather Service recognize the need to address the current costly and aging system. Unfortunately, the program's multi-decade timeline is undeniably slow and will be too late for so many in need. Typical environmental depictions only show two-dimensional rain and wind images based on a single radar feed. While useful, this lacks additional details which can be crucial for severe weather detection. Current systems require the need to open multiple windows to view individual radar feeds over the area of concern. That requires the user to then mentally piece together the applicable parts from each image to determine what is important. StormQuant solves this problem by allowing the user to select any available radar over the region and then meshes the data for use in a single viewport. As shown here over Kansas and Oklahoma, the Frederick radar is toggled on, then Oklahoma City is layered in, next Dodge City, and finally the Wichita radar is added, creating a single, common operational picture and significantly improving the user's understanding of the environment. Additionally, it allows for the creation of detailed three-dimensional imagery and true wind speed estimates for threat evaluation not attainable with a single source. Meshing data from multiple radar sources allows for the creation of cutting-edge, three-dimensional environmental depiction. StormQuant's Weather Viewer allows the user to instantly create vertical and horizontal cross-sections at any desired location in the map area. The benefits of area-wide three-dimensional visualization include detailed storm interrogation to determine movement and development for improved placement and timing of warnings. In addition, it allows for layering of flight paths and launch trajectories embedded within the environmental data to determine the need for manned aircraft, drone, or rocket near real-time rerouting for safety or need for cancellation. Typical radar depiction of wind velocity are color shadings representing the component of the wind directly toward or away from the radar. StormQuant creates estimates of true wind speed and direction, which can only be achieved by meshing the radial data from multiple independent radars. The right side of the screen displays radial velocity from 3 independent radars. The left shows arrows depicting the estimated wind speed and direction calculated from the radial data. By removing storm motion, we can isolate storm relative winds to visualize potential rotation of mesocyclones and tornadoes. Centered, we see the development of cyclonic rotation in the lower levels of the atmosphere. This indicates a potential tornado and provides additional detailed information in an area of concern. Notice the increase in wind speed intensity on the east side of the rotation, shown by the warmer colors of the directional arrows. StormQuant is expanding possibilities of wind interpretation through innovative application. StormQuant's custom-tailored alerts allow the user to choose a specific geographic area and have the system autonomously monitor for heavy rain, hail, rainfall accumulation, or excessive winds. If any selected weather parameter exceeds the set threshold, the system can send emails targeted to specific personnel or organizations for safety or security response. An example is shown here during the Central Texas floods. Heavy rain flagged alert symbols, and 3-hourly rainfall accumulation exceeded double-digit inches in areas as indicated by the pop-up numerical value. The Weather Viewer includes numerous interface tools like the storm tracker pins displayed here. The location, direction, and the speed of the storm is displayed, along with the distance remaining to chosen map location. When combined with the alert notification features, becomes a powerful instrument for rapid response. Finally, state-of-the-science radars are built and deployed to mitigate or eliminate horizontal and vertical radar gaps in the current infrastructure. This advanced hardware's relatively low cost allows for a large network of deployed radars to fill current data gaps and maximize meshing capabilities. Additionally, the small individual radar footprint increases the available number of deployment locations and structures, as well as the ability for mobile, emergency platforms. Finally, the Internet of Things approach opens the door for complete remote monitoring and control of the network and each radar's functions. StormQuant's innovative software and hardware data integration, application, and visualization allows the user to enter their areas of concern once. The system will then continuously monitor, alert, and notify of potential threats to infrastructure and population, allowing for rapid attention and response. The future is now, at a fraction of the cost, at the speed of need. Better data, better tools. It's time to take the next step with StormQuant.